Hi, thanks for tuning in with us. I'm Edward Screven, Executive Vice President and Chief Corporate Architect here at Oracle. Today I'm excited to share some news with you about MySQL HeatWave Lakehouse. Now, as folks are trickling in here, let me give a little overview of what to expect from today's event. First, I'll kick things off by providing behind-the-scenes insight into the latest innovations into MySQL HeatWave. And later in the program, you'll hear from Forrest Norrod, EVP at AMD. He'll explain how underlying AMD architecture helps to power MySQL HeatWave's impressive performance. Now, before we dive in, a quick housekeeping note. Make sure to use the comments feature to ask any questions you may have throughout our conversation, and we'll do our best to respond back to as many of you as possible. So let's get started. Now, MySQL HeatWave first went production about 2.5 years ago, so in December of 2020. Now, since that time, we've made tremendous strides. Many innovations. What MySQL HeatWave is a combined OLTP and data warehousing database. So we can do both transactions and analytics together in the same database. Now, this is pretty unique. If you look across the industry, there's really only one other database that does this well, and that's the Oracle database. Every other database out there, it's either focused on OLTP or it's focused on querying, on analytics or data warehousing. MySQL HeatWave does both. It runs transactions well, and it does analytics very well. It does data warehousing well. And today we're going to talk about how we're expanding the reach of what we can do in data warehousing and in analytics. Because MySQL HeatWave is a MySQL database service, it has exactly the same programmatic APIs, exactly the same SQL dialects as ordinary MySQL. So if you have existing MySQL applications, you can migrate them to our MySQL database service with HeatWave without changing them. So in fact, we have Oracle Analytics Cloud, which has an interface to MySQL, and it works perfectly well against MySQL HeatWave without any changes. Your applications will work that way too. MySQL HeatWave has the best performance in the industry for data warehousing. So here are some numbers for a 10 terabyte TPC-H benchmark. We're 4.2 times faster than Redshift. We're more than 3 times faster than Snowflake. We're 5.6 times faster than BigQuery. We're 7.4 times faster than Databricks. We always say this, and I'll say it again. We make these benchmarks available to you to run yourself on GitHub. Just download our code. You can see exactly how we ran them, and you can verify for yourself. We encourage you to do so. Now, you might be wondering about the cost. We run much faster, but we also cost less. 13 times better price performance in comparison to Redshift. We're faster and we're cheaper. You multiply those two factors together, we're 13 times better than Redshift, 28 times better than Snowflake, 28 times better than BigQuery, 62 times better than Databricks. MySQL HeatWave is by far the best performing and best price performance database for doing combined online transaction processing and analytics. And actually, there's another cost factor here which may not be apparent. Redshift, Snowflake, BigQuery, Databricks, they're good at one thing. They're good only at querying data. They're looking at some of those performance numbers, you wonder how good they really are. But they don't do transaction processing. MySQL HeatWave, because it does both transaction processing and querying and analytics and data warehousing, you get both of those functions for the same price. If you use Redshift, for example, you're also going to be paying for something else like Aurora. You don't have to pay for 2 different databases if you use MySQL HeatWave, or if you use Oracle database for that matter. One of the most important new capabilities that we added to MySQL HeatWave since we first released it is automatic ML, what we call AutoML. So it's fully automated in database machine learning. So that means using MySQL HeatWave manages the training. It helps you choose all the parameters for the machine learning algorithms. It helps you choose the algorithm itself. All of that runs in the database. All of it is secure. All of it is fully automated. It's 25 times faster than similar capability at Redshift and has a broad range of machine learning capabilities, including regression, recommendation, classification, many important kinds of machine learning tasks that for your enterprise applications, for your cloud applications. It's all included at no additional cost. Now, there's a couple things here which I think are especially important. One is that our AutoML is explainable, because very often it's not clear why a machine learning algorithm has chosen a certain result. Why did it classify a customer as a credit risk? We have explainability features that let you understand why the machine learning algorithm made its choice. The other very important characteristic is you don't need to be an expert. Machine learning is very powerful, but using most machine learning tools, you have to be an expert. You don't need to be an expert in machine learning to use these machine learning tools that are part of MySQL HeatWave. MySQL HeatWave, of course, is available in OCI, in Oracle Cloud Infrastructure, but it's also available in AWS. We actually run MySQL HeatWave instances in AWS. If your data is in AWS, you can easily use MySQL HeatWave to process that data. We also run in Azure. Our Azure solution is based on fast network connections that we have between Azure data centers and Oracle Cloud Infrastructure data centers. So you can have your middle tier running in Azure, talking over a low latency network to MySQL HeatWave running in OCI. We have many customers now using MySQL HeatWave. I'll give you a few examples. So Tetris migrated from Redshift and Aurora. Their application is marketing analytics. They use AutoML forecasting to predict their return on ad spend. AI Call, they provide services to financial institutions. They use AutoML to actually predict whether or not customers are likely to be late on payments. Astuda, they provide online services to universities. They migrated from RDS and BigQuery to MySQL HeatWave. They have 300 times lower response time using MySQL HeatWave than they had with BigQuery. We've talked now about generally what MySQL HeatWave is, and we've talked about how some of our customers are using it, and the fact that it has amazing performance and has amazing price performance. But you know, there's a massive amount of data that's not stored in any database. It's stored in files. I mean, databases today are used as systems of record, right? Files are a repository for lots of kinds of data. They're just generated by processes around us. You know, IoT data, you know, web content, log files. Lots of different kinds of data is just stored in files. In fact, most of that data it's collected, it's never really used. In fact, by some estimates, 99.5% of all collected data remains unused. Well, why is that? Why isn't it just stored in a database? Well, for one thing, the applications that generate that data themselves, they're just designed to work with a file system abstraction. I mean, if you're a programmer, it's very easy to open a file and write some data, right? It takes a little bit more sophistication, right, and work to actually store it into a database. If you want to take data that has a simple structure like a CSV file, and you want to move it into a database, you have to transform that data, right? And when you move the data into a database, not only is it transformed, but it has to be formatted and written to some kind of persistent storage in a way which is designed to work well with the database itself. You know, and that has a cost. Always has some kind of cost. A lot of times, file-based data, it rapidly changes, right? And so that means that if you index your data in the database, that means you have to constantly rebuild those indexes. You have to constantly update statistics about the data so that you continue to have good performance. You know, the reality is a large fraction of the data out there in the world does not require transaction processing, and it doesn't really require it doesn't really justify the work required to transform it into those data structures, you know, that databases are designed to use. So how do we solve that problem? Well, we're solving it with MySQL HeatWave Lakehouse. What MySQL Lakehouse is the ability to run high performance, scaled out queries against data stored in files in Object Store. Files like CSV files, Parquet files, exports from other databases. We can take those files, load them into MySQL HeatWave nodes. You know, those are the elements running inside a cloud infrastructure that actually do the processing. We can load them directly into those nodes and run queries directly in the memory of those nodes without any kind of ingest into MySQL. There's no transformation into the persistent storage representation of MySQL. We load them directly into the memory of those nodes, and we can scale that out. We can load it into a single node, we can load it into 2 nodes, we can load it into 512 nodes. We can attack huge scale problems of data stored in these files. And it happens in real time. I mean, the system is always available for all operations. The data in the cluster is always balanced. We take care of all of that for you. You don't have to do any of that for you. You can scale the system up, you can scale the system down. Now you might wonder, well, how hard is this for me to do? It's incredibly easy. Part of MySQL HeatWave is something we call Autopilot, which is a large collection of machine learning algorithms that we use ourselves in order to make MySQL HeatWave be fast and convenient for our customers to use. Well, we've added MySQL Autopilot features that can examine the data stored in Object Store and infer the schema, understand how many nodes we're going to need to load the data in, create balanced, kind of balanced internal plans that we use to load the data into the memory of those MySQL processing nodes. All you need to do is run Autopilot, point it at the files that you want to load. Autopilot will generate the DDL required to actually tell MySQL HeatWave about the metadata, describing those files, and then you run a query, and that's it. In this particular example, I've created a table which has sensor data, which comes out of some kind of log file stored in Object Store, and I'm running a query against it. And you notice there's actually a join there. Sales is a table which could be a table stored in MySQL database. You can combine queries of data stored in files and data stored in the normal MySQL database service files. You can query both file data and database data together. So I mentioned MySQL Autopilot. It is that collection of machine learning algorithms that we use to make HeatWave run fast and be easy for you to use. I mean, it does things like, of course, choose good query plans. Decide like how big of a MySQL HeatWave instance do you need for your particular application, right? In particular for Lakehouse, it's very important because given just the data files, just given the collection of data files, it figures out what resources will need to be provisioned. It figures out the schema. So in other words, here's just a bunch of CSV files. What's a schema that represents it? It does something we call adaptive data sampling because we need to collect statistics, from the data in the files to understand how to query it efficiently. But of course, you might have hundreds of terabytes of data. How do you do that efficiently, right? It automatically parallelizes the loading. So we can stream from object storage, right, in multiple parallel streams into the memory, right, when we're loading it into memory query, right, and on and on. So let me give you an example. Here, we've asked MySQL Autopilot, to help us provision MySQL HeatWave Lakehouse given some files. It automatically determines the number of nodes that we should be using. We don't have to do any sort of like guesswork. We don't have to try, let's first try, like 20 nodes, then let's try 40 nodes. Oh, maybe 30 nodes is a sweet spot. We don't have to do that. Autopilot tells us how many nodes we need. We don't have to go out and stare at the CSV file and try to figure out, well, what data is in the columns of the CSV file? What is the actual data that we find in the Parquet file? I mean, sometimes files like Parquet, they have metadata. Sometimes files like CSV, they don't. But even in a file that has some kind of metadata, the metadata is usually insufficient for creating a database schema because it doesn't have enough constraints about the data encoded into the metadata. Autopilot takes care of that. It looks at the data using adaptive sampling to efficiently determine a schema, a good representation for the data that's stored in those files. We talked about how Autopilot helps you decide how many nodes that you need to use, right? When you're to hold the data in memory that you're going to be querying from those files. Well, you might ask yourself, well, okay, how long does it take to actually provision all those nodes? It's very fast. It's very fast. I mean, the time to provision a single node is a little less than 12 minutes. The time to provision 512 nodes, right, is a little less than 16 minutes. So provisioning scales very well. The provisioning is fast. Okay, how about query performance? I've decided to skip the process of transforming the data into a convenient representation for the database and just query it directly out of those files by pulling it directly into memory. What did I give up by doing that? I mean, is it still fast? We have run a 500 terabyte TPC-H benchmark. That's 500 terabytes. That's an amazing amount. Okay? We are dramatically faster than every other database out there. Every other database. 17 times faster than Snowflake, 17 times faster than Databricks, 9 times faster than Redshift, 36 times faster than BigQuery. Incredible. One important part of why we're so fast is, again, MySQL Autopilot. MySQL Autopilot both analyzes the data to determine statistics statically, but it also watches the execution of queries. And what it does is it learns. It learns from one query execution to the next, like what might be a better plan. And it doesn't just do that on a query by query basis. It looks at parts of queries. So for example, in this particular case, what you see is you see the join tree for one particular query. And by looking at the results of querying, of joining A and B as a subpart of that first query, it can figure out what is a good choice when it runs query 2, a different query that happens to also have a join between A and B. That kind of technique and others is what enables us to run so fast in MySQL HeatWave and MySQL HeatWave Lakehouse. Now, okay, so one thing we talked about before, we talked about the performance of querying. What about the performance of loading? Because you do have to move the data from object store into HeatWave memory, just like you have to do in these other databases. Well, how do we compare about loading? We load twice as fast as Snowflake, 6 times faster than Databricks, 9 times faster than Redshift, 8 times faster than BigQuery. So the time between wanting to know an answer and getting an answer is much, much faster with MySQL HeatWave Lakehouse. One of the reasons why it's so fast is because we use Autopilot, to help guide a scaled out loading process. So we can constantly monitor the network load, the load on the underlying object store, and all of the network elements in between in order to tune and optimize dynamically as we're pulling that data in. Deloitte says, HeatWave Lakehouse scales out very well for loading data from object storage and for running queries on object store. It's key to efficiently process large amounts of data. Natura says, data is growing exponentially, and so is the amount of data we store in our data lake. Obtaining real-time insights from this data is very important for Natura, and MySQL HeatWave Lakehouse could represent a new competitive weapon. Of course it does, and it does for all of you. I mean, if you want to beat your competitors, you need to take better advantage of the information you have at hand than your competitors. That's how you win. And using tools like MySQL Lakehouse helps you do that. Now, you might wonder, like, okay, so great. So MySQL HeatWave Lakehouse, I mean, it's very fast and compared to competitors. How about if we compare MySQL HeatWave price performance? How about if we compare MySQL Lakehouse to just regular HeatWave? What if I took the time to transform the data and store it in a MySQL database? It doesn't matter. You don't need to take the time to store it in MySQL HeatWave. You get exactly the same performance, you get exactly the same price performance, and it's much, much better than every single one of the other choices out there. Now, if you're a programmer, you probably use VS Code, at least for some part of your daily work. I urge you, if you do, please check out the MySQL Shell plugin for VS Code. We've added MySQL Lakehouse support integrated into that plugin for VS Code. It makes it very convenient to use if you're a programmer. So one point I want to make here again is just to emphasize again. We ran a 10 terabyte TPC-H query, including HeatWave, HeatWave Lakehouse against Snowflake, AWS, and others. Exactly the same performance between HeatWave and HeatWave Lakehouse. You give up nothing other than the time it takes to ingest the data into the database if you use HeatWave Lakehouse. You can simplify data management with HeatWave Lakehouse. With MySQL Autopilot, you can analyze the data, a terabyte of data in 8 seconds, 400 terabyte files in under a minute. You can provision HeatWave Less than 12 minutes for one node, less than 16 minutes for 512 nodes. You can load the data into those nodes, those query nodes, quickly. 1 terabyte in a little over an hour, 500 terabytes in a little over 4 hours. The query time is amazing. 6 seconds for a 1 terabyte workload, 47 seconds for a 500 terabyte workload. MySQL Lakehouse, it scales. It also includes standard MySQL SQL syntax. Existing tools that you have that run against MySQL will run without change against MySQL Lakehouse. If you have transaction data that you want to join against the file data that you stored in object store, no problem. MySQL Lakehouse does that. Now, what do analysts say? Well, analysts are overwhelmed. They're incredibly positive. They recognize the amazing engineering that we've been doing over the last 2.5 years. Every 6 months, we've released amazing, compelling new capability to you, right? They understand it's dramatically faster. They understand it's dramatically lower cost. And they recognize the value that we have of AutoML, true AutoML, built right into MySQL HeatWave Lakehouse. MySQL HeatWave Lakehouse gives you the best query performance and price performance for data warehousing. It lets you query data stored in object store. Lets you query OLTP data stored in MySQL Database. It gives you the best load performance in industry. And with MySQL Autopilot, it lets you automate data management. It's very easy to use MySQL HeatWave Lakehouse. HeatWave scales 1 node to 512 nodes, half a petabyte of data, probably far more than any of you actually need to process. Now, we recently had the chance to hear from Forrest Norrod, one of our partners at AMD, on the topic of MySQL HeatWave Lakehouse. He was able to detail how AMD's underlying architecture powers MySQL HeatWave's impressive performance. Let's hear now from Forrest.
The AMD and MySQL HeatWave engineering teams have a close partnership, and it's great to be part of your announcement today. MySQL HeatWave performs different kinds of processing: transactional processing, in-memory analytics, machine learning, and now data lake workloads. Each of these workloads has different resource requirements: compute, I/O, memory bandwidth, and object store requests per second. MySQL HeatWave has been optimized for AMD EPYC processors for all of these workloads, achieving industry-leading performance and price performance. One of the key reasons MySQL HeatWave gets such compelling performance is that its code is optimized to balance various system resources on EPYC, such as compute, memory bandwidth, I/O, and cache lookup. In addition, many of the query processing primitives like bit vector copy and column decompression leverage SIMD instructions and benefit from reduced branch overheads. Query processing constructs like Bloom filters are tuned for the cache size of AMD processors. Further, AVX instructions are leveraged in various aspects of query processing, such as Bloom filter lookup and hash computation. Our teams also communicate regularly about the EPYC CPU roadmap and new and exciting features of the upcoming AMD EPYC processors, enabling the HeatWave engineering team to design and optimize code to maximize the benefits from new processor capabilities. We look forward to continued collaboration with the Oracle MySQL HeatWave team, and we thank you for the partnership and the opportunity to be part of this exciting announcement.
Thank you, Forrest, and thank you for working with us on that benchmark and the incredible numbers we were able to produce for that gigantic TPC-H benchmark. For more information on MySQL HeatWave Lakehouse, please visit us online at oracle.com/MySQL.